Hi everybody, here is a quick discussion of binomial probabilities and how to use the template to calculate them. Okay, so as I'm seeing in the discussion, binomial probability is when you have an action that you repeat over and over and over, but that action can only have two outcomes. So for example, if somebody makes a free throw in basketball, you either make the free throw or you don't make it. Okay, maybe you give somebody a blood test for a certain disease. The test comes out positive or negative. Okay, maybe a state is looking at traffic accidents and they want to find out what's going on with fatal traffic accidents. Someone either dies in the accident or they don't. Okay, so for binomial probabilities, we're repeating the process. We want to know how often something occurs. So maybe Fred makes 5 free throws and we want to know the probability that he's going to make 3 of them. Okay, maybe you test a certain number of people for diabetes and you want the probability that fewer than a certain number will have diabetes. This might happen when you're testing a new diabetes drug. Maybe you know that you would expect to have 4 people out of 25 have diabetes, and you want to know if the drug is effective, so you want to know if the drug has fewer than that number. Okay. All right, maybe a state has made some improvements to a traffic circle or an intersection. Okay, and they know that last year 30% of those accidents were fatal, and so this year they study the first 10 that happened in the year, and they want to know what's going on with that intersection. Has it improved or not? So that's what binomial probabilities do. Let's look at the parameters. Here's the formula for binomial probabilities, but I'm going to show you how to use Excel to calculate this for you. Okay. The n in this formula is the number of trials, the number of times something is repeated. So Fred, in throwing his basketball shots, that would be 5 basketball shots that he makes, not how many he throws. Okay, not how many he makes or how many he doesn't make, how many he actually throws. Okay, for the diabetes example, if you test 25 people, that's the n. Okay, if you look at 10 traffic accidents, then that is the n, the 10 traffic accidents you look at. Okay. Now, the probability that the thing that you are looking at in a single time the process is done, that's what the p is in this probability. So for that, we usually look at old records or something. So Fred has a record of making 5 free throws. 5% of his free throws, that means that p is going to be 5% or 0.05. Maybe in the general population, the probability that a single person has diabetes is 11.3%. And actually, that's what it is. I looked it up. So p would be that probability that a single person has diabetes. Okay. Last year, maybe the traffic accident, 1.6% of the traffic accidents were fatal, so p would be 0.016. And then k is the number of things that you want the probability of happening, or the thing that you're studying. This is worded very well. So if we're looking at the probability that Fred makes 3 of his shots, the k is the thing that you're looking at, that's 3. The probability that fewer than 4 people have positive diabetes test, then k is the 4. Okay, the probability that more than 3 accidents are fatal, then k would be 3. That's the thing you want the probability of. So let's look at the template that I've given you and how to use that. Let's look at Fred. He makes 5 free throws. We want the probability that he'll make 3 of them, and his past record is 5%. He typically makes 5% of his free throws. Okay. So he's making 5 shots. N equals 5. Okay. His past record is 5%. So the p is 0.05, and we want the probability, whoops, sorry about that. We want let's try this one more time. We want the probability that he makes 3, so k equals 3. Let's come and look at the template now. When you look in the template, you'll see that there are a whole bunch of little tabs down here. We're looking at binomial probability, so we're going to use the binomial calculator. And you're going to see when you open it up that you have a lot of these error symbols. Don't worry about that. I'll show you what that is in a minute. So for this, we want to know the N and the P. Those are given to us. He made 5 3 throws. And notice what happened when I put that 5 in? This moved to 5. If I change that to 10, or let's not make, this fills down to 10. So that's why you got those ends there for different situations. So he makes 5 free throws. His probability of making any one of those shots is 5%. So I put in 0.05. And here's what we want. We want to know the probability that he makes 3 of them. Here's how I'm going to read this. There's the 3. And this column right here is the probability that he makes X is exactly equal to the K. So here's the probability. We want the probability that he gets exactly 3. And then here is the 3. So I cross those two, and that's my probability. Cool? Let's look at the next example. "25 people are tested for diabetes. The probability that fewer than 4 of them have diabetes. The rate in the general population is 11.3%. We tested 25 people total. So that's my N. My P is equal to 11.3%, 0.113. And the thing we want the probability of is fewer than 4. So K equals 4. Now, to do this by hand, you would have to figure out the probability that none of them, the probability of none of them having diabetes, the probability of one of them having diabetes, K equals 1, the probability of 2 of them having diabetes, and the probability of 3 of them having diabetes, K equals 3. And then you would have to add these up if you were going to do this by hand. But the template will do this for us all at once, okay? So let's take a look at the template again. The N is 25 people. Okay, oops, and this only goes to 20, so I'm just going to fill this down. These formulas will carry down. So there's my 25 people. The P was 0.113, and we wanted the probability that fewer than 4. So what we want really here is that K is less than 4. That's what we want because of the fewer than. So on our template, this row is the 4, and here's the fewer than, X less than 4. So I take the row with the 4 and the column with the less than, and where they intersect is my answer. Okay. All righty. Let's look at the last example. There's one little sneaky thing on this you have to think about. So a state studies all 10 traffic accidents at a certain intersection in a year. We want the probability that more than 3 of them will be fatal. Last year, 1.6 of all accidents were fatal. There are 10 traffic accidents total that we studied, so that's my 10. The probability that a single accident is fatal is 1.6%, 0.016. Okay, and the thing we're looking at the probability of is more than 3. So K equals 3, but we really want K greater than 3. So if we were going to do this by hand, we would have to calculate the probability for K equals 4, K equals 5, K equals 6, all the way down to K equals 10, because there were 10 of them all together, and we would have to add all those probabilities. So let's look at the template. N equals 10, P equals 0.016. Okay. And we want to know more than 3. Okay. Oh, we don't have a more than. We have a greater than or equal to, but we don't have a greater than. So let's come back and think about this. If we want more than 3, that is greater than or equal to 4. So on the table, I'm going to look at 4. Okay, more than 3 is the same as greater than or equal to 4. So here's this, the greater than or equal to. Here's my 4. So this is my answer. How on earth do I read that? Let's take a look. This is Excel's way of using scientific notation. That E tells you we're using scientific notation. So here's what this means. 1.274, the E means times 10 to the power, and the -05 is the exponent. So there's the answer. Or if I wanted to make it as a decimal, you know, you would use your decimal place 5 places to the left. So 4 zeros, 1, 2, 7, 4, and that's. So I hope that shows you how to use the template. It can save you a little bit of work on the homework. Thanks very much. Talk to you later. Bye-bye.